Here's another document that you should print that we are going to continue going back to over and over again. So the terms on this document form really the backbone of what we're going to be discussing throughout the course. And a couple of the words on here, I actually talked about in day -1. Okay, so in day -1, I talked about compare and contrast. Right? And I am of the opinion that if you don't compare and contrast multiple times in one lesson, something is wrong. All right, so you've already heard me talk about that. And what you're going to do is this is a Word document so that you can continue, when you want to take notes on it, you should save this on your computer and then just type right in. So by the end of the semester, you've got notes in your own words under each one of these terms. Sometimes I'll share the notes that I wrote for you. All right. Other things that you've already heard me talk about, and we're going to read about these in a minute, but the look for and make use of structure and look for and express regularity and repeated reasoning, those are two process standards. And I gave you my interpretation of those where I think the structure of math, as I said in day -1, that some of the structure in math is that we always need like terms to add. We never need like terms to multiply. All right. And that things we do when we want to change the appearance, but not the value, things we do in that case are we add 0, we multiply by 1, we substitute anything for its equal. So that is my interpretation of the structure of math. Okay. It's going to look a little different when you read about it in a few minutes. All right. But I've already talked about that. The very first lesson plan that we're going to look at then, auxiliary lines, okay? And what I'm asking you to do right now, or before the next class period, is I'm asking you to, so let me stop share this for a minute and go to that lesson plan. Okay, first thing that I'm going to ask you to do is try to do the anticipatory set and read over the front page of this lesson plan. Okay, and we'll be working on this together on Thursday. But notice here, and this would be brand new words for you, the procedural goal and the conceptual goal. These are my objectives. Okay, and I know the people downstairs in Block 2 from School of Ed, they don't like the conceptual goal because you've been taught that your objectives have to be measurable. Okay. And so a conceptual goal is, how do we really measure that precisely? Okay. It's harder to measure. That doesn't mean it's not important. So I'm going to agree to disagree with some of the things that they might have taught you downstairs about you only list objectives that are measurable. Okay. Because it's very important that you have a distinction between what we want students to do procedurally and what we need them to understand conceptually. All right, that will be really important to you in writing your EdTPA assignment during student teaching. And I hope all of you have heard of the word EdTPA. See, this is why I wish we were in class, because I would look out at all of you and say, have all of you heard of EdTPA? And you'd all nod your heads. And if you all nod your heads, I wouldn't say any more about it. If some of you are shaking your head no, then I would talk about it. So I'm not really sure right now if I should talk about what the EdTPA is, but right now, right at this moment is not the time or place. So when we are in class, I'll have to survey you on that, whether you've heard of that yet. I'm sure you've not heard good things if you have heard of it. It's a pretty massive assignment that you have to do during student teaching, and it's actually considered a certification exam. So anyway, I want you to try the anticipatory set. Okay, so we've got 9 dots here. You need to connect the dots by drawing 4 straight lines, and it is possible. Okay, so I want you to try that, and then we will pick up with this lesson plan together on Thursday. But anyway, right now, going back to this document on the vocab, let's fill in a couple things here together. So I want to focus on then the terms procedural fluency and conceptual understanding. And just so you know, we use these so often that I will abbreviate PF and CU. Okay, so I want you to immediately get comfortable with those abbreviations. And then I do R for reasoning and PS for problem solving. And so what is procedural fluency, right? And it's just like it sounds. And I'm not writing a formal definition here, but let me describe that as just, you know, what are the students learning to do? What computations do we want? Okay. Now, conceptual understanding, kind of as it sounds. I mean, again, I'm defining things, but they are how they sound like they are. That's small. There you go. So conceptual understanding is what I'm not sure why I don't know. I'm having issues here with my cursor. I'm not quite sure why. But anyways, no, I don't want it big, huge. Sorry, bear with me here for a second. So conceptual understanding is that they understand the reasoning or logic behind the computation. Okay, so we teach them to do a procedure, but do they understand why they're doing the procedure and why the formula is what it is? All right, that sort of thing. And both of these are equally important, right? We need students to be able to get answers, but we need them to be able to understand what they're doing. Another question that we're going to talk about that I'm going to plant the seeds of this question right now is, do we need procedural fluency to have conceptual understanding, or do we need conceptual understanding to have procedural fluency? Right? Like which goes first, or do they kind of wind around each other? Right? Where we have to have some conceptual understanding to learn a procedure, but it's not until we learn some procedures that we can really conceptually understand what we're doing. All right, so how are they related? That's a question that I'm going to plant now and answer later. So one of the things that I think is a great teaching technique is ask questions that you don't answer right away, right? Because I could ask a question and the smartest student in the class will answer it. And then all the other students in the class have missed out on the opportunity to puzzle over this question. So that's a technique that I've used in some of my classes where I write a question and I put it on the board and I tell students to think about it, and smart students will immediately raise their hand and say, oh, I know the answer. And I say, nope, please don't say the answer out loud. Let's give the rest of the class a chance to try to think about this and figure this out. Which brings me to another word, another term on this sheet, inquiry-based learning. And I will argue that the very first lesson that I'm going to present to you is an inquiry-based lesson, right? And what an inquiry-based lesson is really what I just described, right? The teacher asks a good, intriguing, interesting. It helps if it's interesting. Intriguing. Oh, I guess I spelled intriguing wrong. Intriguing. Good. Intriguing. Well, now I really spelled it wrong. There we go. Intriguing question that the students grapple with before any formal instruction is given. In the process of grappling with the question, students learn what the teacher intends to teach them. Right? So, and this is really, again, the first article that you're going to read, Teach Through Problem Solving. You give the students a problem, they play with it, and then in the process of that, they learn what the teacher is hoping for them to learn. And therefore, the teacher's job is to ask a good question and provide a good summary at the end, right? And then the students do all the work of learning. So that's really an ideal way to teach. I'm going to try to teach you in that way. And most of the lesson plans that I'm going to model for you are inquiry-based learning types of lessons. So I think for the moment, I mean, there's so much here. And like I said, you know, we're going to be coming back to this document over and over again. We're not going to learn the terms on here in a linear fashion because first of all, I kind of think of this class as me sort of like throwing a whole bunch of stuff at you all at once, and then you kind of sorting it out, which is how a lot of learning happens. We try to make learning happen in a nice, linear, organized fashion, but it doesn't always work that way, right? Learning is messy, and especially in this class, I feel like your learning is going to be kind of messy, where I throw a whole bunch of stuff at you and hopefully you are able to kind of compartmentalize, this goes here, this goes here, this is this, and pick the pieces out of the big, huge glob of stuff that I throw at you, right? That's kind of my approach for teaching the class. But in general, I want to argue that that's actually an excellent way to learn. So that's all on that document for now.